Hey, this is part 2 video for chapter 2, section 3. And these are systems of inequalities. So not just one line that's been shaded, but two lines that have been shaded. So if you watch part 1 video, what we did was we would do each problem, shade each one as we went, and see where they overlap. So just for the heck of it, on number 3, I'm gonna try to graph both lines first and then shade it when it's done, just to see if you can figure out which area to shade. And if you can't do it that way, then don't do it that way. All right, first things first, though. In the top equation, I do not have it in slope-intercept form. However, I'm going to remind you of a detail. And if you remember this, great. If you don't, that's okay, too. The cover-up method was another option for graphing. And the cover-up method was to say we could just cover up the 4x, forget about him, make him go away, and solve what's there. Now, the only problem here is we're talking about greater thans and less thans, but it still ends up telling you that y is 4. So in other words, the y-intercept would be 1, 2, 3, 4. So if you don't feel comfortable doing it this way, don't do it this way. So let's see. If I were to cover up the 3y instead, that 3y goes away. I would just have the 4x and the 12. And I could divide by 4. And I got 3. And my x-intercept would be 3. So that's just a reminder of a different way to do graphing. Most people like slope-intercept form. So while I'm getting the line feature here, can you please check it out and tell me if it's going to be a solid or dashed line? Well, both these guys have the equal symbols underneath, and if they have the equal symbols, then we know we're making solid lines. Okay, now, two ways to go from here. You could go ahead and shade this guy right now. So that first problem said greater than, which means I would shade above. I'm just going to wait until the end and see if you can figure out which corner to shade at the very end. And if you don't like doing it this way, again, don't. All right, bottom equation. I'm going to do slope intercept form for that one. So I need the y by itself, means I have to move the x to the other side. Done. But I have to get rid of that negative sign. So we did say you could just switch signs, right? So if I switch the signs there, as long as I switch the signs here, that's legal. However, technically, that was a -1. And how do we get rid of it? We divide. That's what switches all the signs. And hopefully you remember this little detail. When you divide by negative, you're supposed to flip the inequality around. And that makes a big difference because I'm going to shade in a different spot. All right, the line itself, though, I'm going to graph like normal. There's a -2 on the end, which makes my y-intercept -2. My slope is 1 over 1. And again, this guy does have an equal sign underneath it. And if it has an equal sign, that means we are going with solid line. So to finish the problem, well, we just have to shade it. So which corner do you think? Top, bottom, left, or right? And so that's why it makes it difficult for some people to come up with this. But here's one way you can think about it. So the red line that we did was greater than. If it's greater than, that means it had to be an above. So it has to be above the red line no matter what. The second one we did was less than, which is below. So where is above the red line but below the blue line? Well, right here is above the red line, and I'm still underneath the blue line. So there's the shaded region that represents the answer to that system. Now, if you feel more comfortable shading each one as you go, and I'm going to do that on number 4, then do it that way. All right, number 4. X only. If it says X only, then I think it makes sense to put a dot on an X-axis instead of a Y. And again, if you committed this to memory, you would know that if all you have is an X, it makes a vertical line every time. So there we go. This is my vertical line. So I'm going to shade this one as I go. So since this one says less than, but it's an X, and I can't go above or below, but I can go left or right. So where the X is smaller than 1, that would be over here on this side. So if that's all we were doing for this problem, I'd be done. That'd be the shade. All right. If you watched part 1 video, I had already pointed out that this bottom equation or bottom inequality has an absolute value symbol. And absolute value symbols are supposed to be V-shaped. So let's make sure we're drawing a V. So what would be the vertex for that guy? Well, if you recall, we're supposed to switch the sign of the guy inside. We're supposed to leave the sign of the guy outside. So my vertex would be -1, -2, which is right there. And another way to do absolute value graphs is to think in terms of a slope. So I can go up 1 and over 1. And if I go up 1 and over 1 on the other side, that would give me my V shape. So this guy does not have an equal sign underneath. He's a greater than symbol. So I'm going dashed with this one. So it says greater than. Where are we going to shade? Well, I got to go above. So if I'm going to go above a V, it's got to be inside of the V. So let me grab some blue to shade with. And I'm going to shade inside my V. But to get the answer to a system of inequalities, you were supposed to be looking for where the shades overlap. Well, my one shade didn't go past the vertical line. And my other shade didn't go below the V. So this funky looking shape right here, almost like home plate, is the area in which the shades overlap. And that's the answer to the system. Okay, again, some math teachers make you erase the other shades, but I don't really care. So as long as you darken in one, we know where it's at. All right, bonus round. So we got to do 3 graphs. Notice, no absolute values. Understood to be +0 on the end of that guy. So I would start here, up 1 over 3. Could go down 1 over 3. That's got an equal sign underneath, so I'm going solid line. Now, if we were in class, I would challenge you to try to do all 3 graphs and then tell me where it gets shaded. But I don't see the point of that. Let's just go ahead and shade that guy. So that one was less than underneath. So I know my answer, my final answer is not above that line. All right, second one, this guy. I see a +1 for a y-intercept. I see a -4/3, so I got to tilt this guy to the left when I'm done with it. Down 1, 2, 3, 4, over 1, 2, 3. Could go up and over instead. Solid or dash for that one. I do not see an equal sign underneath that guy, so I've got to go dashed. Cannot use the screencastify feature. Thanks a lot, guys. Got him. That guy's less than. If he's less than, I want to shade underneath my blue line. So if all we were doing with those 2, then that bottom section would be where the answer is, because that's where my 2 shades overlap. But we got one more to go. Okay. Folks, please. This is not that hard to memorize. Y only. Got to be on the Y. Y only is horizontal. I do see an equal sign. And if I see an equal sign, that means I'm making a solid line. Shade. Let's see, what color should we shade with? Let's go with that. Yellow, sure, why not? All right, that one is greater than, which means shade above the horizontal line. So where do all 3 shades overlap? Well, a little tougher to tell, obviously, when you have more than 2 lines. But right here in this triangle, I see yellow, I see blue, and I see gray. Oops, I missed a little bit. Okay, and you could double check, look up here in this section. No, it's only got 1 shade. Over here's got 2 shades. Down here's got 2 shades. Over here's got 2 shades. But the only place that had all 3 shades was that triangular space in the middle. Again, some math teachers will make you go back and erase those areas that I have X'd. Just as long as you color it in solid for me, then I know that you know where the correct region is, where all the answers exist. All right, folks, thanks for watching. This is conclusion of Chapter 2 notes. See ya.